Okay, number one, state the domain and range of this function. It's a parabola. Parabola, let's say the domain of that is all real numbers. That's pretty simple. To get the range of it, I would draw a picture of it. It's a parabola that opens upwards. The vertex of it, just by inspection, pretty easy to do. It's just going to be -1, comma -2. So the range of this thing, this goes on forever. The range of it, looking at it, well, it starts at -2. That's the lowest it could be. It does touch it, and then it goes off to infinity. That's done. Next up, question number 11. Question number 11, let me make sure I've answered number 10, though. Yes, they asked for domain and range. It didn't ask to graph it. So 11 was, it is an arithmetic problem. So let's write this down. It equals 3. I got to get everything in terms of I or I squared. So I squared to the 15th power would be 30. Minus 2, well, I'm going to get 29 now, so it's going to be I squared to the 14th times I. That's 28 plus 1, which is 29. Minus I squared to the 6th power plus 5I squared I. Again, I'm writing every term in terms of I and I squared. Minus 4 I squared cubed. That's going to be 3. I squared is -1. Minus 2. I squared again is -1. Minus 1. Minus 1. All right, a lot of writing, right? So let's take a look at it, make sure I've done everything correct so far. 30. I'm just looking at the exponents now. 20 at 29. 12. Let's see, 4 and 1 is 5. And 2 times 3 is 6. Looks pretty good. Let's get the coefficient right. 3, minus 2, minus 1, 5, and a minus 4. Let's do the arithmetic now. So what do you get over there? -1 to the 15th power is a -1. That's -3. So the next guy. -1 to the 14th power is +1. So I get -2i. Let's see. What do you get there? -1 to the 6th power. That's going to be 1. So you're going to get -1. All right, let's keep going. Next up, you're going to get 5i. Let's see if I did that right. -1 squared is 1. And 5 times I is just 5i. Last but not least, you're going to get -4 times -1, which is going to be +4. All right, let's add things together. I'm going to add the real parts together first. -3, -1, +4. Well, that's going to be 0. Let's add the imaginary parts together now. So it's -2 plus 5, which is +3i. I would simplify that. It's okay to write this way. This is fine to write that way. But I would just simply say 3i. Both are acceptable answers, by the way. Let's do the next one. The next one says write an equation with roots. I notice they're only giving me quadratic choices, by the way. So what I'm going to do is write down, it would be x minus the root. So it's going to be -3 minus I. And it's going to be x minus the other root, so -3 plus I. Let me multiply it out. You get x squared minus 3x plus ix, right? I distribute that x across those three terms, by the way, x minus 3 and I. Let's do the -3 now. What are you going to get? You're going to get -3x, and then -3 times -3 is +9. And then you're going to get -3i. I'm going to do this now. What do you get? You're going to get minus ix. And then you're going to get, let's see, you're going to get 3i, plus 3i. Then what do you get? You get minus I squared. All right? What do you get now? X squared minus 6x. The ix's disappear. You get 9. The 3 i's disappear because minus 3i plus 3i is 0. And then minus I squared is going to be +1. So now you get +10. Now, I have to look at the key now and see if I see that answer. And do I see an answer where this thing is, by the way, this is equal to 0. We're looking at the roots, by the way. This should equal to 0. Sorry about that. So let's look at it. Do I see x squared minus 6x plus 10? I do, as the first choice. That's letter A, x squared minus 6x plus 10. All right, let's go to the next page. And the next page is you're given a fourth degree polynomial, and it's a real coefficient polynomial. So what am I expecting to see in this thing? I'm expecting there's going to be 4 roots in it. Let's see what the questions are, and I'll answer each question separately. So the first question is, use the rational, what are the possible rational roots? And we're using a rational root theorem to do that. So plus or minus, it's going to be a set of numbers. It's going to be the factors of 10, which would be 1, 2, 5, and 10. So 1, 2, 5, and 10. And then the factors of the coefficient of the fourth degree polynomial, the fourth degree term, would be 1. What does this give you? It gives you a very simple set of numbers. So it gives you 1, 2, 5, and 10. All right? So this is the answer for this one. You're listing the potential or possible rational roots. It doesn't mean there are the roots, just they're possible. Let's do the next one. The next one says that you need to divide the polynomial that you were given, which is x4 minus 2x cubed minus 3x squared plus 10x minus 10 by x squared minus 2x plus 2. Let me break that down for you. So x squared minus 2x plus 2. And this is from a long division, by the way. This is x4 minus 2x cubed. Let's see, minus 3x squared plus 10x minus 10. Well, what do you do? What times x squared gives you x4? That would be x squared. Relatively simple. What do you get there? x4 minus 2x cubed. And then you're going to get plus 2x squared. You're going to subtract now. What do you get? Minus 5x squared. You're going to drop the terms down now. 10x minus 10. Well, what times x squared would give you minus 5x squared? Minus 5. Put that over here. What do you get? Minus 5x squared plus 10x, and then minus 10, and a remainder of 0. So I know this is a factor of the problem now. So I'm going to write that down now, because that's the very next question. But again, we're done with this. This is done. We did our division. So what are the factors? Let's write this down. The first factor I'm going to write down is x squared minus 5. The next factor I'm going to write down is that x squared minus 2x plus 2. But they want them written as linear factors, so I need to determine the roots of those individual factors now. Well, if I thought about it, the root of x squared minus 5 would be when x squared equals 5, so what x would equal plus or minus the root of 5. So I'll write that down, x plus root 5, x minus root 5. All right, the other guy I can't factor, and I can't use that thing I did over here, the square root rule. I can use quadratic formula. So let me write this down for you. X squared minus 2x plus 2 equals 0. I'm looking for the roots. Quadratic formula. X equals, well, the bottom's going to be twice the coefficient of the square term, which is 2. Opposite of the coefficient of the linear term on top is going to be 2, plus or minus. And then you're going to get, let's see, the coefficient of the linear term squared, that's going to be 4, minus 4 times the coefficient of the square term, that's 1, so that's 4, times the constant term, which is 2, that would give you 8. And this looks like it's going to work out pretty nicely, by the way. What do you get? 2 plus or minus. Well, 4 minus 8 is minus 4, and the square root of minus 4 is 2i. So what do you get? X equals 1 plus or minus I. So I get some pretty easy answers over here. It's going to be x minus the root, so x minus 1 minus I, and then x minus 1 plus I. So it's completely factored. They said 4 linear factors. We put in 4 linear factors. What are the roots here? It's going to be a set of numbers. The first root is minus root 5. Then you're going to get plus root 5. And then you're going to get that 1 plus or minus I. So put down 1 plus I, 1 minus I. All right, there's 4 roots, and we found all 4 roots. Let's go to the next page. The next page, find the inverse. And again, I realize a lot of students struggle with this. And if you are, all I can say is keep working at it. So what you have over here, the rest can put the domain range of these things over here. And I know that's difficult, but the domain of this one over here, looking at it, the bottom can't be 0. So I'm going to say it has to include the number minus 1, and it goes off to infinity. All right? What's the range of this thing over here? And I know this is more difficult, by the way, and you're not alone. I'm going to say looking at it, it's always a positive number. It's never going to be equal to 0, and it's going off to infinity. All right? Let's do the inverse. I'll write this down, although I don't know it yet. If they're asking for the inverse, I'm going to assume it's a one-to-one function. I'm not going to have to show that. So I'm going to put the domain and range down for this. And the domain of it is going to be 0 to infinity. I'm looking at the range prior, by the way. And the range of this is going to be the domain of the other guy, so minus 1 to infinity. Let's work on getting this f inverse. I'm going to write y equals, I just replace the f of x by y, 1 over the root x plus 1. I'm going to interchange x and y. X equals 1 over the root of y plus 1. I'm going to do a little manipulation, maybe, I don't know, square both sides. So you get x squared and then 1 over y plus 1. I'm going to divide both sides by x squared and multiply both sides by y plus 1. And you get this. All right, I divide it by x squared and I multiply both sides by y plus 1. And then I solve for y. What do you get over here? Y equals 1 over x squared minus 1. And what does that equal? Well, it equals x squared, common denominator. On top you get 1 minus x squared. Let me write that down. Let me do a quick read again. Find the inverse. We did that algebraically. We did it algebraically. Be sure to indicate the domain and range of both f and f inverse. So I did it for f and inverse. And that is done. Let's go to number 15. It's another inverse problem, but it may seem like a confusing question to you. So let's take a look at it. And what's nice about this function is a line. It's certainly invertible. And what I know about it is I know that it's easy to find its inverse. So I'll put y equals, this is going to be minus 2/5 of an x plus 4. Change x and y, you get x equals minus 2/5 y plus 4. Multiply both sides by 5, you get 5x equals minus 2y plus 20. Again, I multiply both sides by 5. What do you do now? Well, I need to solve for y. So I'm going to say 2y is equal to minus 5x. Let's see, plus 20. What I do there, I added 2y to both sides, and I subtracted 5x. Now I'm going to divide by 2. And what is it going to give you? Minus 5 over 2x plus 10. All right? Now looking at the questions, the first one, this is the inverse, by the way. The first question says it's a line with slope of 5/2. That's not true. It's a line with slope of 2/5. That's not true. Let's see if f inverse evaluates the 6 minus 5, though. So I'm looking at f minus 1, evaluated at 6. Does it equal minus 5? I don't know that. Let's take a look at that. What are you going to get? Minus 5/2 times 6 plus 10. Let's see if it equals minus 5, by the way. What do you get there? 3. 2 goes in 6 3 times. Minus 15 plus 10 is minus 5. This is the correct answer. All right, let's go to the next one. And this is number 15. We're going to, this one over here, find two quadratic functions, one that opens upward and one that opens downward. So let's write this over here. I'm going to say, f of x. I'll call this the first one. If it opens upwards, it's a positive leading coefficient. So I'm just going to write down 1 times. 1's the easiest number to use. X minus a half, which would be, minus a minus half, which would be x plus 1/2. And then you're going to write down x minus 2/3. That's one of them. This opens upward. The second one, if you want to open downward, what's that going to equal? Well, it's going to be minus 1 instead of 1. It'll open downward. You get x plus 1/2, x minus 2/3. Now granted, I realize some students want to write it without the fractions. You can. It's not important. We gave them 2 quadratics. It's not multiple choice. I don't have to look for that. All right, let's look at number 17. And number 17 says evaluate this function at a minus 1. Well, what do you get? You get a minus 1 squared plus 2 times a minus 1 plus 3. And certainly I don't see that listed in the key, by the way, so I'll do some work over here. This is a minus 1 squared, which can be a squared minus 2a plus 1. The second guy, well, 2 times a is 2a minus 2 plus 3. Well, I do get a squared. Then I get minus 2a plus 2a. That they disappear, by the way. Then I get 1 minus 2, which is minus 1. And minus 1 plus 3 is plus 2. Do I see that in key? I do. It's letter A. So that one's done. And I guess we need to go to 18 now. And 18, I don't know if it's the last question or not. I got to look at my own notes. I can't remember how long the exam is. 18. Just looking at my own exam, the paper exam that I give you guys. Yeah, I think that's the end of it. So let's put this one down. And this one, what's nice about this guy over here is that the domain and ranges of these problems are both all real numbers, which makes it much easier for me to deal with the problem, by the way. So the domain of these things is going to be minus infinity to infinity. I can do that immediately, by the way. All right. Next thing up, let's put this down. F of g of x. Well, f of, what's g? I got to read it. It's 2x minus 1. And what's that equal to? Well, let's write that down. It's going to be 2x minus 1 cubed. By the way, that's a fine answer. However, if you want to multiply it, you can. Let me hold off a moment on that, though. What's the next one going to be? And I will multiply it out if you want it multiplied out. What's this one? This is g of f. G of f. What's f? It's x cubed. What does g do to it? It multiplies it by 2, and then it subtracts 1. Let me clean that up a little bit. It's going to be 2x cubed minus 1. And again, this is the domain of it, domain of this over here. Again, for the students that want to multiply this out, you can. And I want to point out, you might find it difficult, but you can multiply it out if you want. I want to point out what I mean by that. 2x minus 1, 2x minus 1. And if you take pre-calc 2, you're going to find out it's actually a lot easier than I'm suggesting to multiply this out. You combine these two together, what does it give you? 4x squared. And then you get minus 2x, which is minus 4x. And then you get plus 1. And then you multiply by 2x minus 1. I'm actually going to carry that multiplication out as well, by the way. I'm going to do it by distributing 2x across those three terms. What do you get? 8x cubed minus 4x squared plus 2x. And then what do you get? You get minus 4x squared. Let's see. There's a problem with finding out too. If you make a mistake, it's almost like you're wasting your time doing it. So let's see. Minus 4x squared plus 4x. And then minus 1. Let me add it all together. 8x cubed. Let's see. Minus 8x. Let me see. I think I might have made a mistake somewhere. 2x, 4x squared. Just give me a second to look at this. 2x times 2x is 4x squared minus 2x minus 2x minus 4x. Yeah, I just noticed a mistake in it. I always say, like, doing extra work sometimes can be hurtful. So 8x cubed. Oh, I see it right over here. This is minus 8x squared. You may wonder why I would look at that. I wasn't expecting to see a pattern. When you study pre-calc 2, you notice there's patterns to these problems over here. But that's minus 12x squared. Then you're going to get plus 6x. And then minus 1. Again, we're not expecting you to do that in an exam, but if you did, that would be the answer that you'd receive if you multiplied it out, which is 8x cubed minus 12x squared plus 6x minus 1. But this answer is completely acceptable. This brings us to the end. Thank you so much for paying attention.